गुड मॉर्निंग बच्चों। तो कैसे हैं आप सभी? आई होप यू आर डूइंग गुड। वेलकम टू आवर वन शॉर्ट सेशन ऑन मोशन इन स्ट्रेट लाइन और काइनेमेटिक्स 1D. Over the recent year, NTA has been asking one or two questions continuously from this chapter. So that's why it is important, and more importantly, it forms a bedrock for everything we will do in mechanics. So let's start kinematics 1D. Yeah, agenda of the session. First, chapter overview. In this part, we will quickly discuss some basic concept of kinematics 1D, and then according to trend we will discuss some basic problems. Over the last few year NTA has been asking question based on problems on calculus and graphical graphs, based on calculus and graphs. So especially we will discuss this section, calculus and kinematics and graphs, and also we will discuss PYQ problems. Clear? Here it is the blueprint of our session. Initially we will discuss parameters of motion, and then we will move towards calculus approach, and then motion under constant acceleration, motion with constant acceleration, or motion under gravity, which is known as free fall, and then graphs. So let's start. First, parameters of motion. What is parameters of motion? These are quantities which are used to understand the motion of a particle, like position of particle, displacement of the particle, distance traveled by the particle. By using these quantity we can understand the motion. And in this chapter kinematics 1D, we will discuss only motion in straight line, motion along this straight line. So when we will discuss these quantities, we will also derive formulas by using these quantities of velocities, acceleration. Got it? So the first parameter is position vector. What is position vector? Position vector is a vector which connect observer to object. If here it is observer and here it is object, then position vector will be defined like that. Head of the vector will be on the object and tail will be on the observer side. Got it? Then after position vector, next is displacement vector. Displacement between 2 points or displacement between two positions in a motion is defined by, if here it is initial position and here it is final position, then this vector is known as displacement vector. If observer is on this position, then it will be initial position and it will be final position. Then according to vector triangular's law, we can define this vector is RF vector minus Ri vector. So we can say that displacement vector is a change in position vector. Change in position vector. Clear? If we define the dimensional formula of the displacement, we can say that distance between 2 points or direct distance between 2 points is magnitude of displacement. So it is related to distance or length. That's why dimensional formula of displacement will be L. And dimensional formula and SI unit will be meter. Clear? Then next is average velocity. What is average velocity? Average velocity is displacement vector divided by time interval. Delta R divided by delta T. Delta R by delta T, displacement, change in position divided by time interval, will be known as average velocity. Clear? If we discuss dimensional formula of velocity will be displacement divided by time, or instantaneous velocity. For the instantaneous velocity, we can use differentiation of position vector with respect to time is known as instantaneous velocity. Then displacement, for displacement we use L, and for time we use T. So the dimensional formula of velocity will be Lt minus 1, and SI unit of the velocity will be meter per second. Meter per second is the SI unit of velocity vector. Clear? And the next is speed. Next parameter is speed. Speed is rate of change of distance traveled. Rate of change of distance traveled by the particle is known as speed. Just like velocity, speed is also categorized into two parts. One is instantaneous speed and another is average speed. Instantaneous speed and average speed. What is instantaneous speed? Rate of change of distance traveled with respect to time at a particular instant. If we define distance traveled by a symbol small d, then we can say that d by dt, it represents distance traveled. तो डिस्टेंस ट्रेवल्ड का डिफरेंशिएशन टाइम के रेस्पेक्ट में क्या देगा? इंस्टेंटेनियस स्पीड. एंड व्हाट इज एवरेज स्पीड? टोटल डिस्टेंस ट्रेवल्ड बाय द पार्टिकल डिवाइड बाय टाइम इंटरवल. डिवाइड बाय टाइम इंटरवल. इट इज नोन एज average speed. You got the point? If we talk about dimensional formula, then it will be same as velocity, Lt minus 1, and SI unit will be meter per second. Meter per second. Clear? If we talk about difference between velocity and speed, The first difference is velocity is a vector quantity and speed is a scalar quantity. And another point between average velocity and average speed, which we should also remember. Average velocity and average speed. Average velocity is displacement vector divided by time interval, and average speed is distance traveled divided by time interval. Average distance traveled is always greater than or equal to displacement vector. What I mean to say, delta r by delta t. Delta r by delta t is average velocity and distance traveled by time interval. Distance traveled by time interval is average speed. Time interval is same. Displacement, or we can use mod of average velocity, because we cannot compare vector with a scalar quantity. We can compare vector with vector. We can compare scalar with scalar. Got it? So I took magnitude. So magnitude of average velocity and average speed, इसमें comparison देखना है. Delta t same है. Delta r and distance traveled. Magnitude of delta r, magnitude of displacement is always less than or equal to distance traveled. So we can say that magnitude of average velocity will also be less than or equal to average speed. You got my point? Clear? The next quantity is acceleration. Acceleration is rate of change of velocity vector with respect to time. वेलोसिटी किस रेट से चेंज हो रही है, वेलोसिटी टाइम के साथ किस रेट से चेंज हो रही है, उसे क्या बोलेंगे? एक्सेलरेशन वेक्टर बोलेंगे. क्लियर? बेस्ड ऑन टाइम इंटरवल we can also categorize acceleration into two parts. One is instantaneous and another is average. Instantaneous acceleration is dv vector by dt and average acceleration is delta v by delta t. Differentiation of velocity with respect to time is known as instantaneous velocity. Change in velocity vector divided by delta t is known as average acceleration. And what is the dimensional formula? Dimensional formula is L t minus 2. And what is the SI unit? SI unit is meter per second square. Meter per second square is SI unit. Clear? For 1D, we can remember some basic formulas. In 1D, we use x as a symbol of position, velocity for vector, a for acceleration and t for time and s for displacement. Based on what we have discussed earlier, I can say that v will be dx by dt and average velocity will be delta x by delta t. This is sign of average velocity. Clear? And for acceleration, in vector form, a vector is dv by dt. Then in 1D, we can also say that acceleration will be dv by dt, and average acceleration will be delta v by delta t. Got it? And by using this formula dx by dt, we can also derive another form of acceleration. We can also derive another form of acceleration, which is if we multiply and divide dx, multiply and divide by dx, then dv by dx and dx by dt. Dx by dt is velocity, so we can write v dv by dx. It is an important formula for acceleration if velocity is given as a function of x. If velocity given as a function of time, then we use dv by dt. If velocity is given as a function of x, then we use v dv by dx. You got it my point? In 1D, we will use this formula for calculation purpose. Clear? Next, based on what we have discussed earlier, let's do a problem which is based on distance traveled and magnitude of displacement. What is the problem? A sportsman runs around a circular track of radius small r such that he traverses the path A, B, फिर B to A, then A to B, A to B, B to A, A to B. Clear? A to B, B to A, and A to B. Then what is the distance traveled? What we have discussed? Distance traveled is the length of path. 2 pi r, and what is pi r? Then total distance traveled will be 2 pi r, distance in one revolution, plus pi r, distance traveled in another half revolution. So the total distance traveled will be 3 pi r. And what is displacement? Displacement is direct distance between initial point to final point, or magnitude of displacement, direct distance from A to B. If we define vector, then it will be direction of displacement vector, and magnitude of displacement will be 2r. Diameter of this circle will be displacement from A to B. You got the point? Next, this is the standard result that we should remember. What is the result? If a body travels in a straight line, the total distance is divided into n equal parts. If the total distance is d, then one part will be d by n, d by n. Then these parts are travelled with speed v1, v2, v3 and v1. In this segment, speed of the particle is v1, here v2, v3, and in the nth part speed is vn. The average speed of the total motion, the average speed during this motion will be total distance travelled and the time interval. What is the total distance travelled? Distance travelled is d. Distance travelled is d. And what is the time? T1, T2, T3, T4 and Tn. So we can say that T1 will be distance traveled in the first second divided by speed. So the T1 will be d by n, distance traveled divided by speed v1. And the next d by n v2 and T2 and 3n and so on. So you can see that d will be cancelled and V average will be 1 upon n v1, 1 upon n v2, 1 upon n v3. So we can write down n divided by 1 upon v1 plus 1 upon v2 plus 1 upon v3 and so on. So by further calculation, what we have achieved in the previous part, V average is n divided by 1 upon v1 plus 1 upon v2 plus 1 upon v3 and so on. V average divided by n will be 1 upon v1 plus 1 by v2 plus 1 by v3. You can derive this part. You got the point? So you should remember this equation. N by V average will be equal to 1 by V1 plus 1 by V2 plus 1 by V3, 1 by V4 and so on. And the important part which you should remember is the distance is equal. N equal part, each segment of same distance. You got my point? If every same distance is traveled by with speed v1, next distance is v2, next same distance is v3, then the average speed will be n by v average. We can derive average speed by using this equation, n by v average equal to 1 by v1, 1 by v2, 1 by v3. Clear? You got my point? Here is the next result which we should also remember, and the result is, if a particle travels in such a way that it travels for t1 time with speed v1, next t2 time with speed v2 and so on. So the average speed will be total distance traveled divided by total time. So what will be the total distance traveled? In this segment we can calculate distance traveled by using velocity into time v1 t1, and in this segment v2 t2, next v3 t3. So the total distance will be v1 t1 plus v2 t2 plus v3 t3, and the total time will be t1 plus t2 plus t3 plus t4 and so on. Clear? This will be average speed. अब इसमें एक स्पेशल केस और आता है. What is the special case? If time interval of each segment is also equal, if t1, t2, t3, t4 are all equal, then what will be the average speed? Average speed will be v1t plus v2t plus v3t, v1t plus v2t, t बाहर कॉमन ले लिया है ना, एंड t plus t plus t plus t, n times t से t cancel, then average speed will be v1 plus v2 plus v3 plus vn divided by n. Clear? The next problem is position of a particle related to time is given by x. This is the position of particle. Magnitude of velocity of the particle at t equal to 2 seconds. This problem is based on calculus. By using differentiation, we will calculate velocity. First of all, what is the velocity? And which velocity? Velocity at t equal to 2 seconds. So the velocity is instantaneous velocity. What is the formula of instantaneous velocity? Instantaneous velocity is dx by dt. So if we differentiate x with respect to time t, then what will be the result? 5 t square का differentiation 2t minus 4, differentiation of t will be 1 and differentiation of 5 will be 0. So here it is 10t minus 4. Velocity is 10t minus 4. If we put time, then we will get velocity. At what time velocity we require? T equal to 2 seconds. So at t equal to 2 seconds, v is 20 minus 4. 20 minus 4 is 16 meter per second. So the velocity at t equal to 2 seconds will be 16 meter per second. Got it? Next problem is also based on calculus. What is the problem? Velocity of a body related to displacement x is given by v is equal to under root 5000 plus 24x. यहां वेलोसिटी किसका फंक्शन है? x का फंक्शन है, ये ध्यान रखना है ना. Then the acceleration of the body is अब what is the formula of acceleration? Acceleration is dv by dt, or another formula is v dv by dx. We will use v dv by dx because velocity is here in as a function of x. So if we use this formula for acceleration, for we should write 5000 plus 24x v and dv by dx, differentiation of velocity with respect to x. By using chain rule, I can differentiate it 5000 plus 24x, then differentiation of 24x. Differentiation of 24x will be 24. So this will be cancelled. 24 divided by 2 will be 12 meter per second square. So acceleration of the body will be 12 meter per second square. Clear? The next segment is motion with constant acceleration. If particle moves with constant acceleration, by using the equation v is equal to dx by dt and a is equal to dv by dt, or a is equal to v dv by dx, we derive 4 equations. The one is v is equal to u plus at. What is v, u, a and t? If particle moves in a straight line, here it is initial point, here it is final point. Initial means t equal to 0, finals mean at time t. Velocity at t equal to 0 is defined by u, velocity at time t is defined by small v, and acceleration of the particle is small a, displacement from initial point to final position is s, then v will be defined by v equal to u plus at. How is derived v equal to u plus at? By using this equation, dx is equal to v dt, you can integrate and achieve v equal to u plus at. Clear? And the second equation which should be remembered, s is equal to ut plus half a t square. Third equation, v square is equal to u square plus 2as, and the fourth is s nth. What is s nth? Displacement in nth second is defined by velocity at t equal to 0, u plus a by 2 into 2n minus 1. These equations are known as big four equation for motion with constant acceleration. By using these four equations, we can calculate v, u, a, s, average velocity, distance traveled by using these four equations. Clear? So the first application of motion with constant acceleration, or the problem of motion with constant acceleration. What is the problem? Engine of a train moving with uniform acceleration passes a signal post with velocity u and last compartment with velocity v. So what is the problem? If we consider it is a train, the signal post acceleration is uniform. Let's consider it is a, and it passes signal post with speed u. जब ये ट्रेन इस सिग्नल से पास हो रही है तो उसके पास स्पीड कितनी है? वो u है. एंड द लास्ट कंपार्टमेंट विद वेलोसिटी v. अब ये ट्रेन जब आगे क्रॉस करके जाती है, तो जब क्रॉस करेगी तब यहां तक पहुंचते पहुंचते इसकी वेलोसिटी v हो चुकी है. क्लियर? द वेलोसिटी विद विच मिडिल पॉइंट ऑफ द ट्रेन पासेस द सिग्नल. अब इस बीच में जब ट्रेन स्लोली ऐसे आगे एक्सेलरेट कर रही है, नॉट स्लोली, जब आगे एक्सेलरेट कर रही है, तो जब ट्रेन ऐसे इस पोजीशन पे होगी, if we consider length of the train is L, then this length will be L by 2. Velocity with which middle point of the train passes the signal post is. So we have to find velocity of the train at this position. So what equation we will use? Here it is velocity, acceleration, we have to find velocity, and we have given displacement. So by using initial velocity, final velocity, acceleration and displacement, I can remember the formula v square is equal to u square plus 2as. If we use this formula for this motion, if we consider it initial position and this is final position, so the displacement will be L, final velocity will be v, initial velocity u. we can write the equation. Final velocity is v dash square, initial velocity u square plus 2a, and the displacement is L by 2. Clear? And in this equation, displacement will be L. This equation is applied between these two positions. Final velocity v square, initial velocity u square plus 2a, and displacement will be L. And if we apply this formula for this for these position, then it will be v dash square equal to u square plus 2a L by 2. If we replace 2al from this equation into this equation, then we will achieve v dash square will be u square plus v square minus u square divided by 2. Clear? And the final result will be v dash square is equal to v square plus u square divided by 2. v square plus u square divided by 2. Clear? The next problem is, bus is moving along a straight highway with speed 72 km per hour is brought to halt within 4 seconds after applying brakes. The distance traveled by the bus during this time. In this problem, formula is not the problem. The problem is unit. If we apply the formula, what will be the formula? What data is given? Time, speed, uniform brakes or uniform acceleration, retardation is uniform, and the final speed is 0, and distance traveled is asked. So we will use v is equal to u plus at. V is equal to u plus at. By using this equation, we will find a, and then s is equal to ut plus half a t square. Ut plus half a t square. By using this equation, we can calculate distance traveled or displacement. So what will be the acceleration? V. If distance traveled is asked in meter, then we should convert kilometer per hour into meter per second. So the 72 किलोमीटर पर आवर इसको अगर मीटर पर सेकेंड में कन्वर्ट करें तो 5/18 से मल्टीप्लाई करेंगे, देन व्हाट विल बी द रिजल्ट? 20 मीटर पर सेकेंड. दो फाइनल स्पीड इज 0, इनिशियल स्पीड इज 72 किलोमीटर पर आवर. So in meter per second, it will be 20 meter per second. Acceleration is negative, so I consider it minus a, and the time taken by the vehicle, by the bus, is 4 seconds. So acceleration is 20 divided by 8. Got it? Then we will put this acceleration in this equation. So the displacement will be s is equal to u. 20 time is 4 plus half. A is minus 20 by 8 and the time is 4 seconds. We can calculate this equation easily. What will be the result? 80 minus 20. The distance travelled by the bus will be 60 meter. Distance travelled by the bus is 60 meter. Clear? The next segment is motion under gravity. It is a type of motion with constant acceleration. If a particle is projected vertically upward, then path of the particle will be like this. It will go upward and down, then return to its initial position. It is known as motion under gravity in 1D. So, what result we should remember? If particle is projected from the ground with initial speed u, then what is the maximum height? Well, what will be the maximum height? H. What is the time taken by the particle to reach at the highest point? We consider it t naught. And time of flight, the time taken by the particle to reach the ground is known as time of flight. So the H max, maximum height achieved by the particle is u square by 2g. By using equation v square is equal to u square between these 2 points, initial point and final point is at the highest point. At the highest point, velocity of the particle will be 0. So v square is equal to u square plus 2as. By using this equation, you can achieve h max is u square by 2g. First point to remember. T naught. By using v is equal to u plus at, by using v is equal to u plus at, you can achieve T naught is equal to u by z. Clear? And from initial point to final point, ground to ground, for ground to ground, the time taken by the particle, for this you can use s is equal to ut plus half a t square. During the whole journey, particle return to its initial position, so the displacement will be 0. Initial velocity is u, time is capital T plus half a is minus g and it is capital T square. By solving this, we can achieve T is equal to 2u by z. Clear? अब यहाँ देखो important एक बात जो ध्यान देने लायक है. Time taken by the particle to reach at its highest position is u by z. And total time taken by the particle to return to initial position is 2u by z. So we can say that to reach the highest position, particle will take u by z time, and in the downward journey, particle will also take u by z. So in the u by z, particle will reach at highest point, and in next u by z, particle will reach at the ground. So in the upward journey and the downward journey, time interval will be same. Clear? Time of ascending or time of descending? Time of ascending and time of descending will be equal if gravity or acceleration is constant. If acceleration is not constant, then we cannot say the time of ascending and time of descending will be equal. Clear? Next is graph for motion under gravity. First, velocity versus time graph. Velocity versus time graph will be like this. Because acceleration is negative and constant, so the slope of velocity versus time graph will be negative and constant. If a versus t, then it will be like this. displacement versus time, it will be like this, and distance traveled versus time, the graph will be like this. इस पॉइंट तक सेम होगा, फिर इसके बाद जैसे जैसे डिस्प्लेसमेंट डिक्रीज होगा तो डिस्टेंस ट्रेवल तो इंक्रीज ही होती रहेगी. So the time here is u by z and it is 2u by z. 2 by z and u by z. And what is the maximum displacement? Maximum displacement is u square by 2g. Maximum displacement, maximum height. Maximum height जब अचीव की थी तब तक उसका डिस्प्लेसमेंट मैक्सिमम था. Got it? Next, मोशन अंडर ग्रेविटी में स्पीड वर्सेस टाइम कर्व. We have drawn velocity versus time graph like this. So velocity will be equal to speed if it is positive. तो इस पॉइंट तक तो स्पीड और वेलोसिटी अगर सेम होगा. अब इस पॉइंट में जैसे जैसे वेलोसिटी नेगेटिव हुई, if velocity is -2 then speed will be +2, velocity is -3 then speed will be +3. So by using this concept we can draw speed versus time graph. It will be like this. Clear? Initial speed u and final speed will also be u, and time at the highest point is u by z, and it will be 2u by z. Clear? This problem, so the problem is based on motion under gravity. What is the problem? A gas balloon is going up with constant velocity 10 meter per second. When this balloon reached at height 75 meter, a stone is dropped. The balloon keeps moving up with same velocity, the height of the balloon when the stone hits the ground. So the problem is like this. Balloon is moving with constant velocity 10 meter per second at the height of 75 meter. A stone is dropped from the balloon at the same level. If speed of the balloon is 10 meter per second square, then at the instant of drop, speed of stone will also be 10 meter per second square. After dropping the stone, due to gravity, path of the stone will be like this. So we have to find the time taken by the stone to reach the ground. For calculating the time, we will use the equation S is equal to ut plus half a t square. Why we will use this equation? Because we have given displacement, velocity, and we want time, and we have acceleration. So the displacement will be, if I consider downward direction as positive, then displacement will be 75, initial velocity will be -10, time is t plus half, a is +10, because I have considered downward direction as positive, and the time is t. By using this quadratic equation, we can calculate time 5 seconds and -3. -3 we will not consider. So the time taken by the stone to reach the ground is 5 seconds. In 5 seconds, what is the distance traveled by the balloon? It is moving with constant velocity 10 meter per second. So the distance will be 50 meter. Then the What is the height of the balloon from the ground? 75 plus 50. So the final height will be 75 plus 50. So 75 plus 50 will be 125 meter. Clear? So next we will discuss about graphs. So the basic concept of the graph is, if y-x graph is given, then slope of curve is defined by dy by dx, and area under curve is equal to integration of y dx x1 to x2. By using this concept, we will we will get some important result of vt curve, xt curve and at curve. So by using the concept we have discussed earlier, if I draw xt curve, then slope of xt will be dx by dt, and dx by dt is equal to v. And for vt curve, slope of vt will be dv by dt, and it is equal to a. So slope of vt curve will be equal to a, and area under vt curve will be integration v dt, and integration v dt will be equal to displacement of the particle. Clear? And for at curve, and for acceleration versus time graph, area under at curve will be change in velocity. Clear? Slope of xt will be velocity, slope of vt will be acceleration, area under vt curve will be displacement, and area under at curve will be change in velocity. You got the point? So the problem based on what we have discussed earlier is, we have given velocity versus time graph, and we have to find distance covered by the object in first 4 seconds. So if the particle is moving in positive x direction, then distance traveled will be equal to displacement. So the displacement will be area under curve. So the area will be this, the triangle plus rectangle. The area of triangle is half base into height, and the area of rectangle is 2 into 10. So the answer is 10 plus 20, 30 meter. Clear? The next problem is, here it is given velocity versus time graph, and we have to calculate displacement and distance traveled. So displacement will be area under curve. If the area is under curve is 16, and here 2 into 4 8, 4 into 4 16, and 2 into 4 8. So the total displacement will be 16 plus 16 minus 8 minus 8. So it will be 16 meter, and distance traveled is not negative. So the distance traveled will be 16 plus 8 plus 16 plus 8. So the distance traveled will be 48 meter. Clear? For the calculation of displacement, the area under curve above the x-axis will be taken as positive, and below the x-axis will be taken as negative for the displacement, and for the distance traveled it will always be taken as positive. Clear? Next problem is we have given velocity versus x curve, and we have to find acceleration versus x graph. So first we have to identify the relation between velocity and acceleration as a function of x. So what is the acceleration? Acceleration is v dv by dx. dv by dx is the slope of vx curve. Slope of vx curve from x is equal to 0 to 200 is a positive constant. And v is increasing linearly with x. So if v is increasing linearly with x, then acceleration will also be increasing linearly with x for x equal to 0 to 200. So the graph of acceleration will be like this for 0 to 200, and then after 200 meters slope of vx is 0, then acceleration will be also 0. So the AX graph will be like this. So what will be the correct answer? Correct answer will be first. Clear? This session will be helpful for SCORE 2026. SCORE is the India's largest talent search exam. It is conducted by Sri Chaitanya Academy, and here are 4 steps for getting the scholarship. First, start the registration. Click the register now button to begin. Then verify and fill your details and select your exam dates and time, and pay 150 rupees by using UPI card, net banking, and get your hall ticket instantly on WhatsApp. And then attempt your test. Exam dates and time slot will be selected accordingly. And examination dates for Sri Chaitanya School and colleges are 4th October 2026 and 1st November 2026. And for scholarship for coaching and academy, the examination is scheduled on 11th of October 2026.